We're going to go through unboxing and setup of a Kraken direction of arrival system, not for the purpose of doing direction of arrival, but rather for the plasma experiment, plasma antenna experiment, testing the theory of special relativity that Steffen has come up with to replicate in a different way his experiment. The equipment that comes from Mauser is shown in this box. There's one other box that's not shown here. We'll talk about this very briefly. There's the box. Open it up, get some instructions, and user's manuals overridden by the wiki, which they provide you the URL with. This is the Kraken box itself, and there are the 5 antenna ports, the power port and the data port, both USB-C on the front end. The antenna set, 5 antennas, and you've got all the cables in there for the antennas. Normally they are going to be spread out quite a bit for an actual direction of arrival system to be able to detect the phase differences in the wave between the antennas. This is the Raspberry Pi that's used to run the Kraken DOA software. And there's the power supply for both the Kraken box and for the Raspberry Pi. There's the data cable at the USB-C end that'll go into the Kraken box, the USB 3 end that goes into the Raspberry Pi. Have to have a SSD, but it has to be burned first, and so I use this burning device. It goes into your computer, and you download the image from a website they provide. You have to unzip that and then also decompress that again with XS to get it into an ISO image that will actually burn with the software that they recommend, which is the Balena software. And then you have the HDMI port, which is nice to have so that you can display what is going on inside the Raspberry Pi, even though it's not absolutely necessary if everything's working properly, and you can identify the IP address of the Raspberry Pi so that you can bring up a web browser under the computer to access it. And there's the power port, and actually I switched over to the actual Raspberry Pi supplied power. And there's the display from the Raspberry Pi. As I said, you don't necessarily have to do this, but it comes in handy. And then the data cable. The data cable goes into the Raspberry, or rather the KrakenSDR. And this is the setup, sort of a mock setup for what you would actually do in a direction of arrival system, although what you would probably, you'd have to have a much bigger area to set this up. You plug in the 5 cables to the Kraken and then to the antennas in order, although for the purpose of this plasma antenna experiment that's not necessary. And then power up the Kraken SDR. And then on your computer, which has to access the Raspberry Pi via an Ethernet or via wireless, you bring up the Kraken SDR network and then give the password, which is Kraken SDR. And then you need to find out what the IP address is of the Raspberry Pi, and for that it's nice to go to the HDMI display and type in IP space address and find out what its actual address is. Put that into your web browser that's connected wirelessly to it, and then tell it to go to port 8080. When you do that, then you get the Kraken SDR web interface, which is already shown here. Then you want to update the parameters to the appropriate band. It's going to be in the FM range for this experiment. In my case, I've got a nearby 103.1 megahertz FM station. And in the DOA configuration, you need to specify a radius of 1 meter for the FM band because it's much lower frequency than they are typically using for the direction of arrival. You can see over on the left-hand side, if things are working properly, then you've got all these green telling you that it has figured out how to synchronize all the antennas so that it can detect phase. Once it's up and running, you can click on spectrum, and if things are working properly, then it shows you the band that it's going to be looking at for the direction of arrival algorithms, which is much smaller than the wideband FM. And then you go on to the DOA estimation, and it will give you a graph which says, well, it thinks that it's off at 190 degrees, but of course, since I've faked it out with all these parameters and not set it up properly for DOA, then it's not going to be a realistic indication of any kind of direction. But that's the basic idea before we go on to the actual experimental equipment, which we're not going to do at this point in time.